Okay, I'm going to go through the 10.1, 10.2 review. Here we go. So in problems 1 through 3, we're going to use the Venn diagram that's right here to answer some questions. Problems 1 through 3. So for number 1, what is A intersect B? Remember, this is the intersection symbol. It means everything that's in A and B has to be in A and B. So that's going to be these 3 right here. Those are the 3 we're going to list. Notice I'm using set notation. It's going to be those 3 names. Okay? That is our answer to the intersection part of the question. Now, the second part of it, what is A union B? Remember, this one is the union, so I want everything in A or B or both. So I take all 6 of the things that are in A together with the 4 that are in B. So we're going to list all of them, and I'm probably going to write them on 2 lines. So we're going to have Hayward, Evans, Favors, Carroll, Millsap, Cantor. So I've listed the ones that are in A. Now we put that together with everything else that's in B that we haven't already listed. Remember, these are in B. And I've already listed the 3 that were in A. So now I've got 1, 2, got Burks, and lastly, Jefferson. Okay, close it with our set bracket. Which of the following says which of the following is a complement, but we don't have a multiple choice or anything like that, so we're just going to list everything that's not in A. Remember, this means not A. So not A, and we have other notations. We have not A, or we can say not A, which is the word not. Okay, so A complement, that's what we're writing. Everything that's not in A. So I'm going to start with these 4 that are not in A. And then we're going to list the rest because these guys that are outside are also not in A. So we have to make sure we get Watson as well. All right. So I'm just going to start with the ones that are in B but not in A. And then I'll list the rest. So I've listed the ones that are in B. Now I'm listing the ones that are not in A or B. I think we're almost there. Oops. Murphy. Okay, I think that's it. 4 and 4? Yep. Okay, which of the following is not in A union B? So we need the things, this is A union B, A together with B, but I want the things that are not in there. So not in A union B, that would be everybody that's outside, these 4. They're not in A union B. So those are the 4 I'm going to list. Okay, and that's the answer to that. I'm not going to do the bonus part. I'm going to move on to problem number 4. So in a sample of 70 people, 25 people enjoy watching dance, 40 people enjoy watching ice skating. Go ahead and read through it. Oh, you've already read through it. You should have done this assignment already. Okay, so what do we have? 20 people enjoy both dance and ice skating. So 20 goes right here. This is going to be my dance, and this is going to be my ice skating over here. Okay, so 20 people enjoy watching both dance and ice skating. So we have 20 in here. 25 people enjoy watching dance. I've already accounted for 20. That means there's 5 over here. 40 people enjoy watching ice skating. We've already got 20. That means there are 20 over here. 20 plus 20 is 40, or 40 take away 20 is 20, right? And then what do we have for a total? We have 5 plus 20 is 45. We've accounted for 45 of our 70 people. So outside here, we must have 70 take away 45, which is 25. And we have it filled in. And we're done. Okay, for problem 5, actually for questions 5 and 6, we're going to use the following setup. We have 7 green marbles, 5 yellow marbles, and 4 white ones in a bag. What is the probability of drawing a green marble, then a yellow marble, if the first is returned to the bag before the second is drawn? So this is an independent situation. Independent, because we are putting back the first one before we draw the second one. All right, so probability of drawing a green is going to be, how many are there altogether? 7 plus 5 is 12, plus 4 is 16. So probability of drawing a green is going to be 7 out of 16. 7 greens out of 16 total. So 7 favorable outcomes divided by 16 total outcomes, times probability of drawing a yellow. Remember, we returned the first one before we drew the second one. So there are 5 yellow. I've got 16 in there because I put the first marble back before I drew the second one. 7 times 5 is 35. 16 times 16 is 256. Remember, to multiply fractions, we multiply numerators and we multiply denominators. So 35 out of 276. I'll make that a little more readable. 35 out of 276. And I want you to go ahead and change that also to a percent. So to change it to a percent, we divide 35 by 256, and we move the decimal point 2 places to the right. We get 13.67%. That's what it is approximately. Okay. All right, next question. What is the probability of drawing 3 white marbles in a row if there's no replacement? So the probability that the first one is white is going to be 4 out of 16, which we'll reduce in a minute. Second one being white, remember we're not replacing, so there are now only 3 white marbles to draw from out of the 15 total, not 16 anymore because we took out 1, times there are now 2 white marbles, but only 14 total marbles to choose from. So I'm going to reduce all these fractions. That's 1/4 times 1/5. For this first one, you can take a 4 out of the numerator and the denominator, right? So you get 1 divided by 4, 1 divided by 5, and then 1 divided by 7, because this last fraction reduces by taking out a 2, dividing out a 2. And what we then have, 1 times 1 times 1 is 1. 4 times 5 is 20, times 7 is 140. So our answer is 1 over 140, or if we need a percent, we just divide, and that's 0.007142, and on it goes. We're going to round that to 2 decimal places as a percent. It's 0.71%, so under 1%. All right, let's look at problem number 7. In a group of 40 children, 20 are on a basketball team, 32 are on a soccer team, and 12 are on a soccer and basketball team. We're going to draw a Venn diagram. So, this is going to be my basketball circle over here. This is going to be my soccer circle over here. What I have is 20 are on a basketball team. So these two numbers have to add up to 20. These two numbers have to add up to 32 because there are 32 of the kids that are on a soccer team. And I have 12 that are on both. So I'll put the 12 in the middle. Let's see. 20 take away 12 is 8. So there's my total basketball children. 8 plus 12 is 20. This must be 20 because, well, let's look at it. 20 take away the 12 gets me the 8 left over for the basketball. And 32 take away 12 gets me the 20 that are left over right here. Okay, what does that add up to? 8 plus 12 plus 20 is going to equal 40. 8 plus 12 is 20 plus another 20 is 40. That means I've accounted for all 40 of the children, so there's none out here. Everybody either plays basketball or soccer or both. Now, what is the probability the randomly chosen child from the group of 40 is on a basketball team or is on a soccer team? Well, that probability is going to equal favorable outcomes. How many are on basketball or soccer or both? All 40 of them. That probability is 1. You're guaranteed to have someone that's on a basketball team or a soccer team because all 40 of the kids are on one or the other or both. So the probability is 1 or 100%. There are no children that are not on either one. So our probability is 100%. Okay, next question. Use the Venn diagram below for questions 8 through 11. State our answers as percents. Okay, high school sophomores. All right. What is the probability that when you randomly draw or select a student, a sophomore, that they're allowed to date? Probability that they're allowed to date. Well, how many are allowed to date? That's 17 plus 29, which is 46. How many sophomores are there altogether? 17 plus 29 plus 40 plus 18. Add them up, you get 104. That's 40. That total is 104. So the probability that they're allowed to date is 46 out of 104. And we want to write this as a percent. So we grab our calculator. We do 46 divided by 104, and we get 44.23%. And we round it to the nearest hundredth, which is what we're going to do. 44.23%. We're looking for an answer as a percent. All right, problem number 9. I'm going to go through problem 11 with this diagram. Probability of no curfew. So how many don't have a curfew? 17 plus 18 do not have a curfew. In other words, 35 of the 104 students do not have a curfew. So the probability of no curfew is going to be 35. That's the number of favorable outcomes, number that have no curfew, divided by the total number of students that we're choosing from, 104. So probability is going to be 35 divided by 104. We'll make that a percent. It's 33.65%. I'll use my little approximation symbols. 33.65%. And we're done. Okay, problem number 10. Probability that they're allowed to date and they have a curfew. All right, so let's see what we've got. I'm going to shrink this up just a little bit so we can see a little bit more. All right, allowed to date and no curfew. That's going to be the 29 that are right in here. So our probability is going to be 29 out of 104. We're going to write that as a decimal. It will be, or as a percent, sorry. Write that as a percent. 29 divided by 104. We grab our calculator. 0.27884, because that's a 4, the 8 stays as an 8, and then I move the decimal point over to here, so I get 27.88%. And we're done. 27.88%. Okay, number 11. This will be the last one for this Venn diagram. Probability that they're allowed to date or. So this one was an and. This one is now an or. Allowed to date or have a curfew. So what I have to add up is the 17, the 29, and the 40. I have to add those three numbers. Or I could take the 104 and subtract the 18. Either way. I can do the 17 plus the 29 plus the 40. Or I can do the 104, take away the 18. And I will get 86. So 86 is this total. So the probability is going to be 86, that's the number of favorable outcomes, divided by the total number of outcomes, which is 104. And changing that to a percent, we get 82.69%. Now, this is not the only way to do the problem. There is another way. We could do the probability that they're allowed to date, which would be 17 plus 29, 46 over 104 that we already had, plus the probability that they have a curfew, which would be 69 over 104, and then subtract the 29 over 104. So we could use that technique as well. All right, use the information below for questions 12 through 14. A few classes are deciding on the name of their class pet. Sample of students have been asked to vote on the two choices, Knox or Tyler. Results are summarized in the table. Notice the table is completely filled out for us. We don't have to fill anything out. We do want to answer the 4 questions, though. What is the probability the student from the sample voted for Knox? So, out of the total students, 100 of them voted for Knox, so the probability is going to be 100 out of the total 300. 100 favorable outcomes over the 300 total outcomes. That we can reduce to a 1/3. If we need a percent or a decimal, we can do that. If we need a decimal, it's 0.3333. So percentage-wise, it's 33.33%, or you could write it as 33 1/3% if you wanted to. Some people write it that way, or you could leave it as 33.33%. Either way. Okay. 33 1/3 or 33.33%. Okay, what is the probability that a student from the sample was male and voted for Tyler? So I want males that voted for Tyler. So we'll go to this number right here where we have males who voted for Tyler. The probability that they were male and voted for Tyler is going to be 85 out of 300. If we need our answer as a fraction, we reduce by dividing out of 5 from the numerator and the denominator. If we need it as a decimal, we just grab our calculator and do 17 divided by 60 and get 0.2833. If we need it as a percent, we just move the decimal point. That's going to be 28 1/3%. 28 1/3 or 28.33%. We round it to hundreds. What is the probability that a student from the sample was female or voted for Knox? Okay, I'm going to remind you that we could do it this way. Probability that they're female plus the probability that they voted for Knox minus the probability of both. Okay, probability that they're female. That's going to be 190 out of 300 plus probability that they voted for Knox. So 100 students voted for Knox. It's 100 out of 300. Both female and voted for Knox. That would be 75. So we subtract 75 out of 100. End result is we took these 190 students and we added these 25 because 100 take away 75 is the 25 males that voted for Knox. So 190 plus 100 is 290, and then subtract the 75. We get 215 out of, whoops, this is supposed to be a 300. All of those are out of 300. Reduce by dividing a 5 out of the numerator and denominator. So we get 43 out of 60. If we need to change that to a percent, we just do 43 divided by 60. 71 2/3%, 71.67%. Be rounded to 2 decimal places. And that is our answer. And this is going to be the end of the video.